Actually, we can change the order of reactions under some conditions. See, for example, if I have some reaction, A plus B gives C plus D with some coefficient, I'm not bothered about it, and rate is nothing but K of A to the power X, B to the power Y. And X and Y has to be determined experimentally. Correct? Now, if A is in excess, let's suppose, if A is in excess, and let's suppose this has power 2, or 3, any number, not 0. If A is in excess, even if the reaction continues, the concentration of A will be same, right? Concentration of A will be constant. If the concentration of A will be constant, A square will be constant, right? Some constant value. And then K into this constant will also become some constant value. So the rate, which was A to the power some value, let's suppose 2 here, into B to the power Y. So in this case the order was 2 plus Y. Now I made it Y. How? If A is in excess, A to the power 2 will always be constant, some constant. Then the concentration of A will not decrease. So in that case, K into this A square will be a constant number. And that means this is some constant denoted by some value into B to the power Y. This value will change. Thus, the rate of the reaction has changed from Y plus 2 to Y, or X plus Y to Y. Correct? Hope you're understanding. See, if one of the reactant is in excess, the concentration of that reactant won't change. Since the concentration of the reactant won't change, we can assume this whole value, that reactant to the power some number. If it is 0, anyway it is independent. If it is 1, 2 or 3 or any number, the whole thing is constant. If this is constant, we can take this K into the constant as a constant, and thus the rate will be free of this part, and thus the order of the reaction will go down. A good example is a hydrolysis. So if you do a hydrolysis of, let's suppose, 0.01 mole of ethyl acetate with 10 mole of water, let's see the reaction. So let's suppose I have ethyl acetate, and I have water and acidic medium. I am doing a hydrolysis. This is what you'll get. So at T is equal to 0, let's suppose this was 0.01 mole and this was 10 mole. At T is equal to T, after everything is consumed, this becomes 0. At the max, this will become 10 minus 0.01 mole. Correct? And this is what 10 minus 0.01 mole is nothing but 9.9. 9.99 actually, you see. Yes, 9.99 mole. And this becomes again 0.01 mole, this becomes 0.01. But if you see, the concentration of water here was 10 mole and here it is 9.99 mole. Very less. See, it's almost same. Right? If it is, but this is almost same, not much change. So concentration of water is not changed that much. So for this reaction, the rate was actually some K into concentration of C2H5, COO, C2H5, and concentration of water also. But concentration of water is almost same, so I can write this guy as nothing but K dash C2H5, COO, C2H5. Sorry, CH3 here. Anyway, that doesn't make a difference here. What I'm trying to explain you that this is gone because this is a constant, because K in where I am saying K dash is nothing but K into H2O. This is constant. This is almost 10. So if you see now, earlier the reaction order was 2, but I made it 1. Such kind of reaction are called pseudo order reaction, right? So technically it is a second order reaction, but it will behave like a first order reaction. We'll apply all the formulas linked to first order reaction in this case, because since the concentration of water is so much, this is behaving as a first order reaction. Correct? Let's take one numerical. Hydrolysis of methyl acetate in aqueous solution has been studied by titrating the liberated acetic acid against sodium hydroxide. The concentration of ester at the different times are given below. This is nothing but concentration of ester. Show that it follows the pseudo order first order reaction as the concentration of water remains same, nearly 55 moles per liter during the course of reaction. What is the value of K dash in this reaction? See, hydrolysis of methyl acetate, CH3COCH3 reacts with water to give CH3COH plus CH3OH. This is the reaction, and it is telling that prove that it is a pseudo order reaction. So, and saying that the concentration of water is almost same. Correct. Now the rate is K dash into CH3COH and into water. Now since it is a pseudo order reaction, I am assuming that water concentration is almost constant. So K dash into water will be almost same, and that I can say as nothing but, let's suppose K into CH3COH, where my K is nothing but K dash into concentration of water. Right? Since this is constant, I'm just giving some different value K. I can give K double dash also. This is my rate of this equation. Now if you see from this equation, I can say the first order equation, right? So it's a pseudo reaction, but the first order reactions will apply all the logic of first order reaction. Correct? So if you can prove that this is true, that means things are fine. So let's find the value of K from this data, from at least this data, and then we'll try to find the value of K from this data, right? If both are same, that means this is the first order reaction. That's what you do, right? You have data given and you want to know whether it is a first order reaction or second order reaction. There are 3 ways actually we'll discuss. So one of the ways, substitution of formula. In the formula you substitute and try to get the values, right? If it is same, then you say, okay, yes, this is correct. So let's do this. So K, if you want to find, this becomes 2.303 by T log of R naught by R. Let's take this pair of reaction. Find the value. This becomes 2.303. Time is 30 minus 0 is 30. It is a minute into log of R naught. Initial concentration is 0.85, final is 0.8004. And if you solve this, this becomes almost 2.004 into 10 to the power minus 3 minute. Let's try to find again the value of K from different set. Let's take this set. 2.303 by T log of R naught by R. 2.303 by T is again my 30. 90 minus 60 is 30 minute. Log of R naught, initial concentration here is 0.7538. Final is 0.7096. You solve this, you get almost same value. Since I'm getting same value in this equation, that means This proves it is a pseudo first order reaction. That part is done. The next part is we have to find the value of K dash. The equation we know is K is nothing but K dash into water concentration. K is something which we have found. So K dash will be what? K by H2O. K dash is nothing but K by H2O from this equation. What is the value of K? 2 into 10 to the power minus 3 per minute. And concentration of H2O is what? 55 mole per liter. So if you solve this, you get 3.64 into 10 to the power minus 5 moles per liter per minute. Correct? So that is the value of K dash, because the question is asking me the value of K dash, not the value of K. K, I already found two values just to make sure that the equation which I am using is correct. Right? It is a first order reaction. To prove that, I found two values of K using first order reaction formulas, and both the values were same. That proves that it is a